let's take a look. So here you put it in order. I like to cross them out as I put them in order so I know if I miss any. Right, because otherwise it's really easy to miss some. 43, 43, 44. And then 46, 51, 57. So then let's see, there's 3 this way, 3 that way, 1 that way, 1 that way, 2 in the middle, tied. So average of 43 and 43 is 43. All good? Great. Perfect. All right, next we have measures of central tendency to mode. Justin, go ahead and read.
Measures of central tendency mode. The mode is the value that occurs most often in a data set. It is sometimes said to be the most typical case. There may be no mode, one mode, unimodal, two modes, bimodal, or many modes, multimodal.
Right, so the mode is the one that occurs the most. Did I put that in there? Yeah. So why don't you guys go ahead, I'll give you an example first, sorry, 2 examples. So here's one, signing bonuses. You can clearly see that there are 3 10s, so that's the most, that's the mode. Over here, there are, oops, undo. Okay, there are 504s. There are also 509s. So they're tied for the most. So we have 2 modes. It's bimodal, 104 and 109. Please note, if there's one more 109, then 109 would win and there'd only be 1 mode. Right? But because they're exactly tied, they both have exactly 5, then it's bimodal. All right, do the mode part of lab problem 1. I'll give you 15 seconds, go. All right, which one occurs the most? 43, there's 2 of them. So the mode is 43. Everybody good? Yes? Great. Mid-range. Do you guys see the word mid in there? Everyone see the word mid? Anytime you have the word mid, that means you're going to find the middle of 2 things. So you're going to average 2 things, the top and the bottom. Here's the mid-range. You're going to average the highest and lowest values in your data set. So you take the highest and lowest, add them up, divide by 2, average them. That's your mid-range. Here's an example. I'm going to take the highest and the lowest and average them. Mid-range is 180. All right, add them up, divide by 2. You guys find I'll give you guys 30 seconds to find the mid-range on your lab problem. I'll help you out by circling the smallest and lowest, 27, 57. All right, so your mid-range, you guys got 27 plus 57 divided by 2, 42, yes? Great. Moving right along. This is the part where it gets a little bit more novel, a little bit different. How about Angelo? Go ahead and read.
Mean and median. Example, the water temperature at a point downstream from the plant for the last 30 days is summarized in the table. What is the mean temperature for this distribution?
Great. So, this is a frequency distribution. We've seen it before, right? Like the last exam, for example. Here we have 5 people who had 5 days had a temperature of 57, 4 days had a temperature of 56, 8 days had a temperature of 55. Everybody on board with that part? Yeah. All right, so this makes sense to people. So what we should do, if we're going to average them, is we're going to add up each one of these. So since there are 4 52s, we should add 52 4 times. There are 6 53s, we'd add 53 6 times. Everybody kind of on board with this part? So we'd add up all the days, and we get 1637, right? Because we have 3 54s, we have 8 55s, 4 56s, and 5 57s, yeah? Divide by how many there are. There are altogether 30 days. Right? You can probably count them. However, math, the whole point of math is to help us be lazy. So instead of adding 52 4 times, we just take 52 and multiply it by 4, because 4 times 52 is adding 52 4 times, right? 52 plus 52 plus 52 plus 52. So this just gives a shortcut for the adding part. That's all it does. So here, let's do it together. Do it with me in these blanks. So here, this one would be 6 what's? 6 53s. This would be 3 54s, 8 55s, 4 56s, 5 57s. And then we're going to multiply all those, right? And then multiply them. Go ahead and write in the numbers you're multiplying, because that way, someday, when you need to explain this to your younger brother who's taking this class or something else, you'll have the notes and you can see what you did and you can explain it to them better. And then find all these. Calculator and find them all. The beauty of it is that they're all 50-somethings, and 50s are usually easy to multiply by. So let's just multiply by 3 times 50 and 3 times 4. 250 plus 35. When you add them all up, you should get 1637.
Yeah.
Great. And then I need to divide by how many there are. How many are there? 30. Right, my frequency. Now I'm going to go over this kind of when it's simpler, because you guys are really clear on this one. 1637. This is really what? This is really temperature times days, right? Number of days. So this is temperature times days. That's how we got that. And what do I want? Do I want the average number of days or the average temperature? Average temperature. So how do I go from this to just temperature? I need to divide by days. So everyone kind of see that? So I need to figure out how many days do I have? 30. So if I divide by 30 days, then these guys will cancel out. I'll be left with just temperature, which is what I want. So that will give us, I have no idea, 50 something. 50 what? Wait. 6? 5, 6? Rounded to 6? Okay, great. And again, we should have one more decimal place than our original data is in, so round to 1 decimal place. All right, everybody feel good about this one? Yes? No? Because we're moving on to adding another step in. All right, good. Oh wait, no we're not. We're going to do one more. We got 2 more things to do. So here is your notes at the bottom, the top of the next page. The formula. Why am I? Andre, read.
Measure central tendency weighted mean. Find the weighted mean of the variable by multiplying each value by its corresponding weight and dividing the sum of the product by the sum of the weights.
Great. So here we have our x bar, sample mean, is equal to each x value multiplied by its weight. Add those all up and divide by the sum of the weights. This is the same thing as frequencies, right? Every value times its frequency, divide by the sum of the frequencies. It's the same exact formula. So here we have the sum of, remember the symbol is sum of, the weights times each x value times its weight, divided by the sum of the weights. Where x bar is, you're going to fill in stuff here, right? X bar is your sample mean. Should we be writing that in? X is, what's x? Yeah, your data values. Is each data value? your data values. X are your data values. W is your weights or frequencies, the individual weights or frequencies. And the last one, the sum of the weights, is the sum of the weights. SUM, sum. Not SOME. SUM, sum of the weights. All right, now we're going to do lab problem number 2. You're going to do it actually, but I'm going to help you with the beginning of it. So here's the deal. I don't know that if you guys are aware, but the way that classes work, for example, this class is a 4-unit class. This class is worth twice as much as a 2-unit class. If you have a 2-unit PE class, for example, this class is worth twice as much as that one is, if it's 2 units, because this is 4 units. So here, this one is 3 credits, this one's 3, this one's 4, this one's 2. Think of every unit like a little baby grade. So this one, 3 units of A is like 3 tiny A's. Does that kind of make sense for you folks? This is also 3-unit class, so it's like 3 small C's. This is a 4-unit class. Everyone see that? 4 units here? So it's like 4 little baby B's. B, 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 4 of them, because it's a 4-unit class. And this one, D is worth 2 units, so it's only 2 D's. You guys are all familiar with grade point averages, right? A is worth how many points?
A lot.
A lot. How many specifically? 4. So this is like taking 4 4s and averaging them. 3 C's. C's are worth 2 points. B's are worth 3 points. And D's are worth 1 point. So it's just like taking these numbers, the 4, the 4, the 4, the 2, the 2, the 2, the 3, 3, 3, 3, and the 1, 1, and averaging them up. In other words, averaging them. Adding them up and dividing by how many there are. Again, you can do the shortcut though. 3 times 4, 3 times 2, 4 times 3, 2 times 1. That's just to add them up. That's a shortcut for adding them up. You still have to divide by how many there are. So why don't you guys take a couple of minutes and sort this part out. Okay, so how many points do I have from my first class from English Comp?
12.
I get 3 times 4, 12. And here this is going to be 3 times 2, 6. 4 times 3, 12. 2 times 1, 2. And so altogether I have 32 grade points, yeah? So this is what we call grade points, 32, and this is based upon credits times grade points. Is that everybody okay with that part? That's where I got this from. This came from credits times grade points. Do I want to find the average credit or my average grade point? I'm calculating my GPA. What does GPA stand for? Grade point average. So I want to find my average grade point. Everybody on board? In order to do that, I want this. I need to get rid of that. How do I get rid of credits? I need to divide by credits. Because that way I'll cancel out this credits up top. So I need to divide by the number of credits. How many credits am I taking? I gotta find that. So my total credits, right? 12. So I need to divide by 12 credits. And then these guys will cancel out. I'll be left with grade points, the average grade point. So this will end up being 2.66, 666, so 2.67, is that right?
Yeah.
So you can leave it like that because we do typically with GPAs, we usually do 2 decimal places. Or our general rule is 1 more than our data is in. So this would also be totally acceptable, 2.7. 2.7 is what the book would do. I'm okay with This just because in real life, people always do two decimal places for GPA. So either one is fine. Okay. All right, so everybody on board with this part?
Yes, ma'am.
All right, now we got that little step up, it's a little bit tougher. But here it is prettier. So now I'm going to ask you, now I have a situation where I have a grouped frequency distribution. So I have these classes. This class is from 130 to 149. I can't have, I need to find one number that represents that class the best. Should I use 130? Should I use 7? It's the 6th class, 5th class, should I use 5? What's the best number to represent that class? What was that? The last one, 130 to 149. The midpoint. Does that make sense? Because the midpoint is the least far from any spot in that class. So in other words, see how it has one person in it? This one person could be 130, or they could be 149, I don't know, or anything in between. So if say I decided to pick 130 to represent the class, if that's 149, I might be really far away. Or if I picked 149 to represent this class, that one might be 130, I might be really far away. But if I pick the midpoint, I'm least likely, it could be anywhere from here to here. If I pick the midpoint, then the furthest away I could be is half the class. So you guys sort of see what I'm saying? So the midpoint is kind of the best guess, right? So we need to find all the midpoints. So what we do is, for this one, we find all the class midpoints, and then everything else is exactly like we've been doing. Take the frequency times the class midpoint, find it, find all of them, add them all up, and then divide by the sum of the frequencies. Right, because these are scores, IQ scores. This is also IQ scores. So here we have IQ, this is score times frequency, and I want the average IQ score, so I'm going to divide by frequency to get out, to divide out the frequencies and be left with just the average score. All right, so you guys have one. Here are the steps. If you want steps, I don't like steps, but if you're a step person, here's your steps. Make a table, including a spot for your midpoint, and for your frequency times the midpoint, XM. Find the midpoints of each class, multiply each frequency by the midpoint, and then add up your column D and divide that by your sum of the frequencies in column B. You guys need to do yours, which is here. Lab problem 3, miles run. And if you want, if I put up this one, do you guys want this one up there to kind of look at? Okay. Lab problem 3. So spend a few minutes on that, and then we'll take a break until 55 after. All right, so you find all the midpoints of all of them. Incidentally, what's my class width? How do I find the class width from here? Look at 2 consecutive classes, right? So you can look at the class upper boundaries, lower limits or upper limits. Here we have lower boundaries. How far are they apart? 5. So that means it's just plus 5 to get one from one to the other one. So plus 5, plus 5, plus 5. That gives me all my midpoints. And then we multiply each frequency by the midpoint, add them all up, and then divide by how many there are. There are 20 people that were in this survey. 24.5 miles is the average. Well, our best guess is the average. Okay, good. All right. Now, properties of the mean. How about Janessa? Go ahead and read.
Properties of the mean sound like using all of the values of data, it is less than the median of the difference between other statistics such as the variance.
right? So we'll see later how the mean is totally affected by outliers. It's going to come in a video I'll show you guys in a little bit. Properties of the median. How about Adam? Go ahead.
Properties of the median. Gives the midpoint, used when it's necessary to find out whether the data values fall into the upper half or lower half of the distribution. Can be used for an open-ended distribution. Affected less than the mean by extremely high or extremely low values.
Right, that's one of the beauties of the median. We say it's very resilient to outliers. So in other words, here's my data. Here's the median. Half is below it, half is above it. It doesn't matter how far above it is. It could be here, it could be way out there, an outlier, and this is still my median. It isn't changed by that at all. So it's very what we call resilient to outliers. It's also useful, because it splits your data perfectly in half, right? Lower half and upper half. Properties of the mode. Derek, go ahead.
Properties of the mode. Used in most typical cases desired. Easiest average to compute. Can be used with normal data, not always, only not exist.
Right, so mode is useful if we're talking about non-numerical data. You can find the mode of colors, right? Red, orange, yellow, green, blue. Which one occurs the most? But you can't find the average of those colors. So that's the nice thing about the mode is you can use it with categorical data also. Vicki, do you want to go read this one?
Properties of the mid-range easy to compose and accurate by extremely high or low values in a data set.
Yeah. So we talked about mid-range before, right? We had like those 49 people who made $20,000 and the one guy who made $1 million, and that totally affected the mid-range by a whole lot. Right. So that's some of the issues I have with mid-range is that it's very susceptible to outliers. Distributions, we talked about that a little bit previously. So here's a normal distribution, right? It is bell-shaped, so values start off low, and then in the middle, that's where most of them occur, and then it kind of tapers off, and there's fewer and fewer as you get further away from the mean. It's roughly symmetrical, so left half and right half look roughly the same. Then we also have what we call right skewed, where you have an outlier off to the right, which is kind of pulling the data out this way, pulling the mean this way. The median's here, but it's pulling the mean this way to the right, because you have an outlier this way. You can kind of see how it drops down. There's fewer of them. That's an outlier. Here there's an outlier, like a small, very few of them out this way. So it's like it's getting pulled out to the left. This is left skewed. So it's yanking the mean to the left. So when you think about left or right skewed for your homework, think of it as it's sort of anti-intuitive. You have to think about like where the outliers are, where the very few amounts are. There's very few this way to the left, so it's pulling things to the left. What else do we have? Oh yeah, so now we're getting into 3.2. Measures of variation. Range. Everyone see the word mid there? Do you guys see the word mid? Do you? Where?
Would you guys where is the importance?
Yeah, where's mid?
It's not on it.
It's not on there. There's no mid here.
It was a trick.
So it was a trick. Just check and see if you're paying attention. So no mid. So this is not an average. Mid, you take the average, right, of the top and the bottom. That's the middle. There's no mid here. We're not taking an average. It's just highest and lowest, you find the difference, you subtract them. Everybody on board? Mid, if something has mid in it, then you average it. No mid, no average. You're not averaging anything. Everybody on board? All right, so this, the range, you take the highest and lowest and you subtract them. That's how you tell those apart, because people mix those two up all the time. The mid-range and the range. Range, no mid, no average. Just take the top and the bottom, subtract them. Done. Okay. Here is what does it matter? How about Joseph, go ahead.
Say you are buying a television and have narrowed your choice down to 2 models. Looking at reviews, they are similar except the amount of time each lasts before breaking. The table at the right shows the number of months each lasted for its reviewer before breaking. Find the mean and range of each model.
Great. So say this model A is a Panasonic, some particular Panasonic TV. This one over here is some Sony TV. This one, the models are the same. They're all the same number of inches, they're the same size, they're the same, they're both 4K TVs, they have the same number of USB slots, they're the same in almost every way in terms of benefits and everything else. So they're virtually the similar TVs. They all have good reviews, the same amount, they're both like, 4.2 stars or whatever. The only difference between the two, between this Panasonic and this Sony TV is these 6 reviewers have said how long it lasted them before it broke. So for one guy, it lasted 30 months before it broke, his Panasonic. Another guy, his Panasonic lasted 35 months before it broke. This girl, hers lasted 40 months before hers broke. This one lasted 35 months before it broke. This one lasted 30 months before it broke. This one lasted 40 months before it broke. The Sony, 6 different people commented on how long it lasted them before it broke. So one lasted 20 months, 50 months, then it lasted 40 months, and then it lasted 70 months, then it lasted only 10 months before it broke. Right? So these are how long it takes before it breaks. You guys need to find the mean of each model and the range of each model. So find the mean and range of the Panasonic, find the mean and the range of the Sony. Go.